do you think will happen in the next century if we continue constructing our buildings in a traditional way? By 2100, part of UBC, Granville Island, and Stanley Park will be underwater due to effects of global warming. Construction sector contributes more than 40% to greenhouse gas emission. If we want to reach net zero emission by 2050, we need to change the material and the way we construct our buildings. By sustainably harvesting forest, wood is a renewable resource that can sequester carbon dioxide from atmosphere. On the other hand, off-site manufacturing is a carbon-efficient method where almost 90% of the building modules are prefabricated in a factory and assembled on a site like a logo. However, this method is limited to low-rise buildings in an area that the seismic risk is low. And this is mainly because of the lack of confidence on the performance of this box-type building. My research focuses on developing an innovative modular building that combines the timber material with off-site manufacturing. The main idea is providing mega floors that support several layers of these boxes, so these boxes do not need to carry the whole load of the building, and we can build taller in this building. But how we can make sure that this building is safe when a big earthquake happens? We will employ a cutting-edge hybrid simulation technique that is a combination between experimental testing and computer model. The mechanism of our load-resisting system in this building is rocking like this. So most of the damage concentrates at the base of the wall, while the remaining part remain undamaged. So we will construct the first story of this building in a lab that we don't know how it will behave in the earthquake, while the remaining part will be in the computer model. At the same time that we click-run analysis in our computer, we run our hydraulic actuators in the lab. The computer model sends a displacement command to the actuators to impose it to the specimen and return back the force feedback to computer model to update it for the next step. And this will continue until the end of the earthquake motion. At the end, we will monitor the damage in our wall and see if the design procedure we followed was sufficient or needs modification. We finally provide a step-by-step design guideline for engineers to adopt to design these sustainable and earthquake-resistant buildings. Hopefully, adopting this type of buildings will contribute to reducing the risk that our beautiful campus be submerged by 2100.